Hello AAF kids again. This is a separate video that you do not have to watch, but this is going over the homework Graphing Rational Functions 3, because I know there was some hard parts to this one, so I want to make sure that before the quiz on Friday you can refer to this. The first couple should have been fairly routine, where you are factoring. You see your bad X. But that is a factor that canceled out, so that bad X isn't a vertical asymptote, it's a whole.
Sure. Well, thank you very much.
I take the bad X and plug it into the simplified version of the rational function, and plug 2 into here, and I get 2 plus 2, which is 4. So I'm going to go to the graph and graph 2, 4. I note that because my only bad X was a whole, that I have no vertical asymptote. The degree of my numerator is more than my denominator degree. So I'm top heavy, which means I have no horizontal asymptote either. I'm going to wait on the range, so until I find my X-intercept and Y-intercept. Oh no, I won't. I guess I'll go for the range. Since I have a Y value of a whole, I know that for the range I am going to go to I'm going to say all real numbers, and my suspect is, should I kick out the Y value of the whole? So I'm going to go down here to my workspace, and I'm going to ask the function, hello function, will you ever equal the Y value at the whole? And I could use my original function, I could use my factored form, or I could use my simplified form. And I think I will use the simplified form, because the only difference between my rational function and my simplified version is the whole. So I get X is equal to 2, but I remember my domain, and that's a bad X. So what that tells me is that the Y value of the whole is not used, therefore my suspect has been convicted, and my range is all real numbers except for 4. And remember, we talked about in the lesson that I might have a gap in my range that I can only tell from my picture, but when I look at my calculator at this graph, I see what appears to be a line, and that shouldn't surprise you. My simplified version is x plus 2, right? X plus 2 is a linear function, so this rational function looks just like a line except for this whole. I can go now and look for the X-intercept and the Y-intercept. The Y-intercept means plug in 0 for X. And I get 2, which again shouldn't surprise me since it's a linear function. I didn't really need the math to do that. The X-intercept means you make Y equal to 0, and if I have a fraction, when again all I care about is my simplified version. So what is true about my simplified version? I get X is equal to negative 2, which is a good X. It's not kicked out of the domain, so that means I can go ahead and plot there when X is negative 2, Y is 0. Again, if I'd recognized my linear function, I would have known this is true. So now I am just, even without a calculator, hopefully you would know what a linear function looks like, except for the whole. So that's what my graph looks like. I have my axes labeled, my whole, my X and Y intercept, and I have no ha. So that's it. That one wasn't so bad, right? So let's look at the next one. The next one also not too bad. Factoring it really is just a constant. Factoring a constant out. The domain is all real numbers. X is not equal to negative 6, but since that factor didn't cancel with anything, negative 6 is a va. That needs to be labeled. Since I only had one bad x and it's a vertical asymptote, I didn't have a hole. A horizontal asymptote, since I have even degrees, then the horizontal asymptote is at the ratio of the leading coefficient, which is 2 to 1. So my horizontal asymptote is where y is equal to 2. That's my only suspect, since I didn't have a hole. That's my only suspect for the range. The range is all real numbers, but maybe y is not going to equal 2. So I go to the function and ask. Say, excuse me, function, will you ever equal 2? Solve a rational equation means I multiply through by the least common multiple. The 2x's canceled out and I was left with 12 plus 12 is equal to 4, which of course is nonsense. 12 does not equal 4. So that means what I was asking, does 2 ever equal this rational function? The answer is no. So therefore my suspect has been convicted and my range does kick out 2. Oh, I forgot to graph my ha. I go looking for my X-intercept and my Y-intercept. So for a Y-intercept, I plug in 0 for X, and I got 4 over 6, or 2/3. And for my X-intercept, I plugged in 0 for Y, and when I have a fraction, I don't care about the denominator, just what makes the numerator equal to 0, and hopefully you can see that would be negative 2, right? Subtract 4, divide by 2. Right, for a fraction equal to 0, you only care about the numerator to be 0, so I got x is equal to negative 2, which is a good x. So my x-intercept is negative 2, comma 0. So I'm going to go and graph these. So I have negative 2, comma 0. And I have my y-intercept, 2/3. 0 and 2/3. Now I look at my calculator. Please, please, please make sure when you are graphing that you put parentheses around your entire denominator in your calculator and your entire numerator. So when I put in big numbers for x, I see that I slide under on the right and slide, I get positive numbers, or numbers just above 2 on the left and just below 2 on the right. So that's my slide. I look at my vertical asymptote, and on the left side I swoosh up. So I connect that branch. And on the right side of the vertical asymptote, I swoosh down. Remember, 2 is kicked out of the range, so I know I'm not going to hit my vertical asymptote. I'm sorry, my horizontal asymptote, but I sure better hit my x-intercept and my y-intercept, and then slide. Whoops, I hit the horizontal asymptote, didn't I? I didn't mean to. And make sure that you have your arrows and everybody's label, right? Move on to number 3. So number 3 has a common factor of x in the numerator, so factor that out. And the denominator has x minus 3 and x plus 3. That's so weird. Why am I doing that? Notice that my bad x before canceling cannot equal 3 and x cannot equal negative 3. However, since x minus 3, which goes with the bad x of 3, canceled out, 3 is a whole, but negative 3 is a vertical asymptote. So I'm going to go and draw at negative 3, my vertical asymptote. The whole, I have to take the 3 and plug it into this simplified version. So that would be 3 over 3 plus 3, which is 6. So that's a half. So I know how I have a vertical asymptote at x equals negative 3 and a whole at 3 comma 1/2. The horizontal asymptote, since I have even powers, the horizontal asymptote is at the ratio of the leading coefficients, which is 1 over 1. Therefore, my horizontal asymptote is at 1. I'm going to go, which means I have a suspect. For the range. So my range is all real numbers, but my suspect is y cannot equal the y value of the whole. Y cannot equal the y value of the vertical asymptote. So the y value of the whole was 1/2, and the asymptote is 1. Right, those are the two suspects. So I have to go to the equation and ask it. Hello equation, function, will you ever equal 1/2? Right, solve a rational equation. Which is a good x. So that tells me that 1/2 is cleared. Now let me ask about 1. Whoops. Silly me. Silly me, I knew that that was a... That was bad math. Or I knew I shouldn't have gotten a good x. So sorry, it's 1 times x plus 3 is equal to 2x. So x is equal to 3, which is a bad x there. So that tells me that 1/2 is not cleared and 1/2 does get kicked out of the range, which I knew. That's why I knew my math was wrong, because I could see it. So next I'm going to ask again. I'm going to ask if 1 could ever equal the cleaned up version. So this time, will x ever equal x plus 3? So I get 0 is equal to 3, which is nonsense. So both of these do get kicked out of the range. So they're no longer suspects, they are convicted. Now I have to find my x and y intercepts. So my y-intercept is plug in 0 for x and I get 0. So y of 0 is 0 over 0 plus 3, which is 0. And then my x-intercept is what will make this equation equal to 0. So I say x-intercept, where can I fit this? X-intercept, what does make 0 equal to just the numerator, right? I remember when you're looking for a fraction to be equal to 0, all you care about is the numerator. So when x is 0, y is 0, which means my x and y intercept is at the origin. And when I look at my calculator, I can see that I slide on the right, I'm under the horizontal asymptote, and on the left, I'm on top of the horizontal asymptote. I can see that I swoosh up on the left side of the vertical asymptote, but swoosh down on the right side. I know I'm continuous everywhere else and that I don't hit the horizontal asymptote, so I know I'm going to swoosh, connect that piece. I know I don't hit the horizontal asymptote, but that I must swoosh up from here and hit my x and y intercept, hit my hole, go across my hole, and then slide. I have trouble with my slides over here on the scale. It's terrible looking. But I have arrows everywhere, right? All done. Number 4. Whoops. Number 4. Factor out an x and you get x squared minus 16. Factor out a 2 and you also get x squared minus 16. Now those two factors will cancel out, but I hope that you can see that there are actually 2 bad x's that go with those factors, right? X cannot equal 4. X cannot equal negative 4. Since both of those bad x's cancel out, though, neither one of these is a vertical asymptote. They're both holes. And the simplified version is just 1/2 x, or x over 2, right? That's a linear function. So this whole nasty thing is going to look like a line, except it's got what? 2 holes. No vertical asymptotes, because both bad x's canceled out. How do you find out the y value of the hole? That's right, plug in 4 here. Plug in 4, then you get 2. Plug in negative 4, and you get negative 2. So 1, 2, 3, 4, 2. 1, 2, 3, 4, negative 2. And then again, I hope you can see 1/2 x is a line, right? It's a linear function that goes to the origin, so your x and y intercept is 0, 0. Hey, I don't have a ha. Oh, right, I knew that. I'm top heavy, right? When your numerator is bigger than your denominator, you've got no ha. Now what about my range? My range is all real numbers, except for the suspects, which are the y values of your hole. But again, I hope you can see from the graph that I can kind of skip the algebra here, that since this is a line, it's not 1-to-1. I'm not going to use a line, except it's not really a line. It's a line except for the holes, but the ends look just like a line. So therefore, I do need to kick out, whoops, the y values of the holes. Now if I asked you to prove it, could you prove that y never hits 2? Prove it. If I say prove it, that just says do the algebra. So that means you plug in 2 into the cleaned up version, and you plug in -2 to the cleaned up version. And of course you get x is equal 4, which is bad. And you get x is equal to -4, which is also bad. Okay, that's the proof. Prove that 2 and -2 are kicked out of the range. Algebra. Alright, now I'm going to start to throw you curveballs. So there weren't really any curveballs so far, but these next ones are nasty. Okay, all 4 of these have something that you haven't really encountered before. So I start to factor the numerator and I realize it's prime. Now remember, prime is for factoring, not for solving. The denominator is not prime. It has a factor of x I can pull out, which means my domain is all real numbers except x can't be 0 and x can't be -5. Since neither one of them canceled with a matching factor, they're both vertical asymptotes. Oh, dagger. -5. So weird when it does that. Come on back. Come on back. Sometimes if I scroll, that's where it helps. Okay, x equals -5. I do have a ha, and it's at the ratio of the leading coefficients because of even powers. And since neither one of my bad x's canceled out, I don't have a whole, but I do have a suspect for the range. So I will ask function, will you ever equal 1? And of course, if any fraction is to equal 1, well then the numerator must equal the denominator. Right? Well, the x squareds drop out, and I get -7 is equal to 5x, therefore x is equal to -7/5, which is a good x. Right? And I had 2 bad x's, and they were 0, -5. So what does that tell you? That tells you that your suspect is cleared. That means 1 gets left in the range. And that was your only suspect, so your range is all real numbers. Unless you have a gap, right? So I'll look at the graph to see I have a graph. There's no algebra with a gap that you know of yet. Oh, weird. Okay, so now I go looking for my x-intercept and my y-intercept. Y-intercept is easy. Y-intercept is anything that makes the denominator, I'm sorry, when I plug in 0 for x, right? So to find my y-intercept, I go to the function and I say y equals 0 squared minus 7 over 0 squared plus 5 times 0, which is -7 over 0, which is undefined, which means what I was looking for doesn't exist. So no, oh, of course I don't have a y-intercept. I have a vertical asymptote on there. No touchy, no graphy. What about the x-intercept? To find the x-intercept, you make y equal to 0. And you only care about the numerator. Now I know x squared minus 7 is prime for factoring, but for solving, how many solutions are there? 2. They just might not be rational. And sure enough, they're not. X is equal to plus or minus root 7, which is like 2-ish, right? So, at 1, 2 something, there's radical 7 comma 0, and at negative 2 something, there's negative radical 7 comma 0. My y-intercept I didn't have. I looked at my calculator and I saw that I slid on top of the horizontal asymptote on the right, slid up beneath it on the right, sorry, left, right. I looked at my vertical asymptotes and I swooshed up on the left of this one and down on the right. I swooshed up here and down here. There's a graph everywhere else. I only touched my horizontal asymptote once, and I found out where that was, at negative 7/5, which is like negative 1 something. So I'm on my horizontal asymptote right here at negative 7/5. Comma 1. And now I just connect everybody else. And I look at my calculator to help me with my shape. Hit the x-intercept, hit the horizontal asymptote, and swoosh. Hit the x-intercept, and slide. Right? So those were the curveball of that one is it had 3 branches, it hit the horizontal asymptote, I found out where, and I had x-intercepts that weren't rational. Alright, so what about the next one? What's crazy about number 6? Well, firstly, you've got a cubic, which I taught you how to factor at the beginning of this unit. I only have one bad x. It cancels out. Therefore, I have a hole. That's my only bad x, so I don't have a vertical asymptote. Where do I have the hole? I have to take 1, the bad x, and plug it into the cleaned up function, which, by the way, looks like a parabola. 1 squared plus 1 plus 1 is 3. So 1, 1, 2, 3. I have no ha because I'm top heavy. So my only suspect for the range is 3. So I have to say my range is all real numbers, but I suspect that y will not equal the y coordinate of the whole. So I ask, and I say, excuse me, function, will you ever equal the cleaned up version? and I got two x's, one was good and one was bad. So no, y will not be 3 when x is 1, because that's the whole. But when x is negative 2, I do use 3. So 3 is cleared. So I think my range is all real numbers, right? But then I look at the graph. And when I look at the graph, I see what looks like a parabola. And it is a parabola, right? Except for that hole. The y-intercept is at 1. There are no x-intercepts because the vertex is below the x-axis. I'm sorry, above the x-axis. The problem is, where is the vertex? Why do I care? Why do I need it? Well, firstly, a vertex is always a critical feature. It's a minimum, right? And in this case, it's the absolute minimum. Use your calculator to find it, or negative b over 2a, right? The x-coordinate of the vertex is negative 1 over 2 times 1, right? Negative b over 2a, which is negative 1/2. Plug in negative 1/2. The y-coordinate of the vertex is negative 1/2 squared plus 1/2 plus 1, which is 1/4 plus 2/4 plus 4/4, which is 7/4. Whoops, sorry. This is minus 1/2, right? So that is 3/4. So my vertex is at negative 1/2, 3/4. Why do I need that? Because my range isn't all real numbers, right? I told you for gaps you have to look at your graph, right? There's a large gap here. My range for this one is goes from the x-coordinate, the y-coordinate of the vertex, which is 3/4, to infinity. Why don't I kick out the whole, which you can of course also write as y is greater than or equal to 3/4? Why don't I kick out the whole? Because 3 is not used here, but this function is not 1-to-1, and it's used over here. 3 is used here, which of course this math told me. So if I asked you to prove why the y value of the whole is used, this is the proof. Okay, so that was a twist to that one. So how about 7 and 8? What is the problem with 7 and 8? Well, here's what I can tell you. For what I'm going to do is I'm just going to draw the graph that I see a lot of times, and then I'll go through the math afterwards. But this is what I see, and this is going to cost you a lot of points if I see this. Okay, that's what I see. Now, what's wrong with that? Well, firstly, there's a lot of things wrong with it. There's a local min that you didn't find. You're supposed to use your calculator to find all maxes and mins. Here's a minimum. There's a minimum there. But you know what else is wrong? Here's the other thing that's wrong. When you looked at this, you saw the numerator that is prime for factoring, and the denominator is x plus 3. So your domain is all real numbers, and x can't be negative 3. Since that didn't cancel, you knew that was a vertical asymptote. There were no other bad x's, so there were no holes. There was no horizontal asymptote because you're top-heavy. So therefore no ha. So I have no hole and no ha, so I've got no suspects for my range. right? But then I told you had to look at your graph. So maybe you did. You looked at your graph, you found the minimum, and you said, oh, my range is y is greater than or equal to whatever that number is. Here's the issue with that. Go back to your domain. You told me your domain was all real numbers except -3. So I see that you don't have a graph at -3. Then I see you have a graph when x is -2, -1, 0, 1, 2, 3, 4, all the numbers in between and all of these numbers because you have an arrow that's going. But where's your graph when x is -4? How about -5? How about -6? How about -7? You said the domain was all real numbers except for -3. But I don't see a graph. Too many of you show me your calculator and go, look, Ms. Getz, there's no graph there. Stop it. Your graph is only looking at, it's only a machine, and its window is set. You know that there's a graph somewhere over here. There has to be. The only place a graph doesn't exist is at -3. So how do you find it? You have a calculator in your hand. I showed you how to do second graph. So you're looking at a table and change the auto to ask. We'll plug in -4, or just plug -4 into your equation. -4, -5, -6, and then go change your window. And when you change your window, you will see that when I start plugging in -4 and -5, I get negative values. And when I change my window to make my negative x's bigger, my negative x's and my negative y's, when I change them, you'll see the other branch. Plus, you also know you have a vertical asymptote. You can't swoosh over here without swooshing on the other side. You have to swoosh. And if you look at your calculator and you look at your table and you plug in numbers really close to -3, you'll see that you swoosh down. You swoosh down, but then you have another turning point. And your graph looks like that. So what does that mean? You have a local max and a local min. How do you find them? Your calculator. And why do you need to know them? Because that gives you your gap. You have a gap here that has to be kicked out of the range. No ha's and no holes, but you've got a gap. Your range goes from -infinity to the y coordinate of the local max, and use your calculator to find that. It's -15, I think. I can read my writing from when I did it. The y coordinate of the local max. Then you have the y coordinate of the local min, which I think is also the y-intercept if I'm looking at it, if I can read my writing. So that's 5/3 to positive infinity. Okay, so that was tricky. But what was my major contributor to figuring it out was realizing I have my domain is all real numbers, I have to have a graph everywhere, and I used my calculator to go find it. Very similar thing is going to happen. Oh, and notice there was no x-intercept either, which I could tell. Right, when I went looking for my x-intercept and y-intercept, I forgot to put the x-intercept and y-intercept on here. But the y-intercept again was 5/3 by plugging in 0 for x, and then plugging in to find the x-intercept, I plugged in 0 for y, and I only care about the numerator. But x squared plus 5, x squared is equal to -5, which is nonsense. Right? So what does that say? It says you have no x-intercepts, which you can see from the graph. Hold on, my doorbell's ringing. I'll be right back.
It's going all right. Actually, I'm recording a talking here.
Oh, yeah, talking.
All right, last problem, number 8. They're down. If you want to go downstairs, Lisa, they're just wrestling down there, I think. This is another cubic and a quadratic.
Come in.
Right? So, this is minus. So what's my domain? All real numbers, but x can't be 2, and x can't be negative 2. But I have a matching factor that went with this bad x, so that's a whole. The other one is a vertical asymptote.
Yeah. We went skating on our pond yesterday. Back there, you know, we have that whole area.
And now it's not.
Right, exactly. But now we can plug the whole.
And the whole is at 2 comma what?
Well, bid.
You're plugging 2
2 hours.
into
I know sometimes it's hard to
here.
look at, you know.
Yeah, it's
Right. The opposite. I want to make sure we really want to do it. Hopefully a little bit better.
Draw my vertical asymptote.
Right, yeah, I mean, we don't have to go all at once, but you have to great. Alright.
So I'm going to plug my
Our big new doggy. Oh, yeah.
into here, and what do I get? 4 plus 4 is 8, 9, 10, 11, 12. So that's going to kind of be up here, right? Just going to put it up there.
Oh, really?
I'm top heavy again, so I don't have a horizontal asymptote. So I only have one suspect. And that's 12. So my range is all real numbers. And I suspect that y can't be 12. Wait a second. Did I mess that up? No, 2 goes into here. Okay. So now, what do? My suspect, I ask, right? Ask. So, excuse me function, and use the cleaned up one. Will you ever equal 12?
That was my feeling. Alright, well it sounds pretty interesting, so. Well, the boys see each other at basketball tomorrow, maybe, I guess. They have basketball and they have OS Friday, I think, Saturday.
So x is equal to -4, or x is equal to 2.
Well, thank you, Lisa. Bye,
But that's the bad x, where the whole was, right? And 4, but 4 is good. So when x is equal to 4, I will also hit 12. So I suspected 12, but it's clear. So I think my range is all real numbers. Until I look at the graph. Now I did go looking for x-intercepts and y-intercepts, and my y-intercept, I plugged in 0 for x, and I got -8 over -4, which is 2. And my x-intercept, I said, when will the numerator be equal to 0? But x squared plus 2x plus 4 is a prime quadratic. Not only is it prime, you can do the discriminant, right, which is b squared minus 4 times a times c, which is minus 16, which is negative. So there is nothing that makes the numerator equal to 0, therefore there is no x-intercepts. And then I look at my calculator, and I do see I have a vertical asymptote, so I know I swoosh. With I'm a rational function, I'm going to swoosh, and I see swoosh this way. And then it kind of looks like this. Oops, this is -4. Ah! See, when you guys aren't here, when I'm not with you, that's a dagger, is that you can't stop me when I make these silly mistakes, and I have to find them out for myself. So there, I hit 12, and I kind of swoosh off. Keep going, right? No horizontal asymptote. It's a terrible drawing, but you get it. And over here, at -4. So I know, here's the thing again, I know there's got to be a graph over here. There's got to be a graph. So I have to go find it. So you get your calculator and you say, well, I don't see it in my original window. So what do? Go look for it. Now I think this one in your Zoom 6 window you did see, right? So you can see that you do have down here. And plus, again, you have a vertical asymptote, so you know you've got a swoosh down. And you see again that you have this local max. So I need to find a local max and a local min, and I use my calculator to find those. So the only thing, must have made a mistake somewhere, because I don't have, obviously at -4, I don't hit the value of my hole again. It's over here that I hit it again. So I don't know, so I need to find that mistake. And then I think also I didn't have my calculator with me, so I think up here I don't know that my local max and my local min are actually correct. I was just guesstimating from a drawing I have. So these values of my local max and my local min I need for my range, right? So my range is going to be from negative infinity to the y coordinate of that local max, and then the y coordinate of the local min to positive infinity. And just use my calculator to find those, and I just don't have it with me right now. And the same here. I don't think this is negative 15 and 5/3. It's just using a bad drawing to guess at those. But that's what calculators are for, right? And then also find my mistake with the whole. Let's see, what did I do? How did I find the whole? The whole, I factored x, this is x minus 2, x plus 2. So 2 canceled out there. So if I plug 2, did I do, oh, is this not, oh yeah, that's right. X squared, 2x, and 4. And if I plug 2 into there, 2 squared is 4, plus 4 is 8, 9, 10, 11, 12. So did I do the factoring wrong? X squared plus 2x plus 4 minus 12 does give me a negative 8, right? Is this correct? That's negative 8. It's positive 2x. So I don't know. I have to think about this further. I can't find my math mistake. Maybe you can find it. For me, and let me know where it is. What did I do wrong here? You tell me. That way I know if you've seen the video, right? Alright. So that's it. I will figure it out too. When I get my calculator, I will look at stuff and look at my math, see what I can do. But in the meantime, you've got a bunch of my examples of me going through 8 examples of what your quiz might be like on Friday. Now the only thing I might add to this is writing out characteristics, right? More like increasing, decreasing, and characteristic list that you might do. That might be on the quiz as well as graphing and labeling. Don't forget, for graphing and labeling you need to do all important pieces, right? Vertical asymptotes, horizontal asymptotes, holes, X-intercepts, Y-intercepts, increasing, decreasing, function continuous, one-to-one, max and mins, local and absolute, right? Alright, I will see you tomorrow.